This is part 6 in the series, An Introduction to the Derivative, and we're going to be starting with the quotient rule. And the quotient rule states that the derivative with respect to x of the quotient of some function f and some function g is given by g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now this may look kind of ugly and nasty and not terribly easy to remember, but there's a little phrase you can use to remember this a little bit easier. Let's think of g of x as the low function and f of x as the high function. So what we actually have is low times the derivative of the high minus the high times the derivative of the low over the low squared. So if we actually put that down, it looks a little bit easier. So we have low d high minus high d low all over low squared. Sounds kind of silly, but it's actually kind of easy to remember once you get used to it. So low d high minus high d low over low squared. So let's try to put this to use in a simple example. So let's say y equals 5x minus 2 over x squared plus 1. So to do the derivative then, we have y prime equals low, which is going to be x squared plus 1, d high, the derivative of the high function, which is simply 5, minus the high function, 5x minus 2, times the derivative of the low, which is 2x, and that's all over the low function squared. Now, to simplify this, let's multiply through. We have 5x squared plus 5 minus, we'll just put those in parentheses first. So 5x times 2x is 10x squared minus 2x. 2x times negative 2 is negative 4x. And that is all over x squared plus 1 squared. Let's distribute that negative 1. So we have 5x squared plus 5 minus 10x squared. Negative 1 times negative 4x is positive 4x all over x squared plus 1 squared. Let's take this on up over to here and simplify. So 5x squared minus 10x squared is negative 5x squared, and plus 4x plus 5. And that's over x squared plus 1 squared. Now before we move on, I want to look at one more example because there's a special point I want to make here, something to try to avoid to simplify your life. Let's say that our problem called for the derivative of this function. Now, for many people, there would be an overwhelming urge to jump right in and use the quotient rule. But if you exercise a little bit of caution and look into the problem, you can simplify your life greatly sometimes. So I want to rewrite this to see if we can put it in a simpler form so that we don't have to go through all the rigor of the quotient rule that we had up there. So the first thing I see is I have a negative 3/7 here. So I'm going to pull that out for the constant rule. So 3/7 times 3x minus 2x squared over x. Now, you should be able to see that we can simplify these expressions because both of these are being divided by x. So what we actually have here is negative 3/7 times 3x over x is just 3, and negative 2x squared over x is negative 2x. Now, if I take the derivative of that, that's all we really have to do for y prime is the constant multiple rule. So we pull out the constant. The derivative of 3 is 0, and the derivative of negative 2x is simply negative 2. So our final result is negative 2 times negative 3 is a positive 6 over 7. And now let's look at the chain rule. The chain rule states that the derivative with respect to x of some composition of f of g of x is equal to f prime of g of x times g prime of x. Now the trick usually with the chain rule is identification of which one is the outer function in the composition, which function is the inner. And it can often be taken several different ways. So let's look at a couple of examples to see what we're talking about. So let's say y equals the square root of x squared plus 1. Now, if we rewrite this, it should be a little easier to see the outer and the inner functions. So this is actually x squared plus 1 to the 1/2 power. So here the outer function is raising something to the 1/2 power, and the inner function is the thing being raised to the 1/2 power. So if we wanted to employ the chain rule, we take the derivative of the outer function. That's what this f prime of g of x is. So for y prime, we make believe this inside term is some value u. Let's call it u. So 1/2, whatever that inside piece is, x squared plus 1, that has to remain unchanged. Subtract 1 from the exponent, so 1/2 minus 2/2 is negative 1/2. So that's the derivative of the outer piece times the derivative of the inner piece. the derivative of the inside piece is 2x. And that is the chain rule. So let's go ahead and simplify this. And you have to be really careful in the simplifications, especially with radical functions, because some things end up in denominators and it gets kind of dicey. So let's just rewrite it as it is and then do some cancellations. So we have 2x over 2 times x squared plus 1 to the 1/2 power. So now we can see that this 2 and this 2 cancel out. So we will have x over x squared plus 1 to the 1/2. And that is a simple application of the chain rule. In this example, we have another instance of some inner function being raised to the 3rd power, which is the outer function. Now, both this example and the previous one that we did before were examples of what's known as the general power rule. So again, if you think of this inner piece as some differentiable function of x, we'll call it u. Let u equal 3x minus 2x squared. Then what we have is y equals u to the 3rd. And so the derivative of this is we're going to take the derivative of y with respect to u, and then following that we're going to take the derivative of u with respect to x. So that's in essence what we're doing. So to do y prime, we take the derivative of y with respect to u. So the derivative of y with respect to u is simply 3u squared. And then the derivative of u with respect to x is we take the derivative of this piece, which is 3 minus 4x. That's a 4. And then we can go ahead and back substitute for our u term. So that would be 3 times 3x minus 2x squared times 3 minus 4x. Now, since this is completely factored, we don't want to go any further, and we're done. Now, in case this u substitution stuff messed you up, we can do this derivative without actually doing any of that u substitution. So let's just rewrite our original expression here and say that's y equals 3x minus 2x squared to the 3rd. So then our y prime would be, pull down the 3 times the inner piece without being modified, 3x minus 2x squared, subtract 1 from the exponent, 2, times the derivative of the inside piece, 3x minus 4x. And there we have the exact same thing. So either way, if it helps you to do some substitution here and take the derivative of this piece and then derive the inside piece after that, that's fine, or you can do it direct. Your choice, it works the same no matter what. And that's the chain rule with the general power rule. The general power rule is a specific application of the chain rule. And now we'll move on to the derivatives of the trigonometric functions.